Okay, so in order to add or subtract, you need a common denominator. We didn't need that for multiplying fractions, right? So to add and subtract, you need a common denominator. And if you knew that, that's great. But if you didn't, make a note. To add and subtract, need a common denominator. So in number 1, we're in luck because we have a common denominator. You keep your denominator. So we keep the 5. And we just subtract the numerators. So we have 1 minus 3, and you get negative 2. Questions on that one? Okay. The next one, we don't have a common denominator. So Austin, how did you solve that problem?
You have to multiply 2 by, first fraction by 2 over 2. Second fraction by 3 over 3.
Good. All right. So the reason we do this is because we can make a common denominator of 6. So if we multiply the 2 times the 3, we get 6. If we multiply the 2 times the 3, we get 6. And you're allowed to do this because 2 over 2 is just 1. So I can multiply something by 1. That doesn't change it. All right, so 2 times 2 gives me 4. 2 times 3 gives me 6. That gets me 3. And then that gets me 6. Excuse me one sec. Okay. This is a multiply problem. Oh, wait, we didn't finish this one. Sorry. Add your numerators. Keep your denominator. Someone asked a good question. Should we make that 1 and 1/6? You can if you want, but I am perfectly happy with an improper fraction of 7/6. For multiplying, do you need a common denominator? No. So for multiplying, remember we did this last class. Numerator times numerator. Denominator times denominator. So we get 2 over 6, which does simplify. So I'm fine with an improper fraction, but not an unsimplified fraction. What does this simplify to? It does simplify to 1/3. Because you can divide the numerator by 2 and get 1, and divide the denominator by 2 and get 3. So 2/6 equals 1/3. All right, number 4, what common denominator are we going to use? 10 would be a good choice because I could multiply just the first fraction by 2 over 2. And then I would get a denominator of 10. Did anybody do the problem with a denominator of 50? Some people who have issues with common denominator, they just multiply by whatever is the denominator of the other number. And you could do that, but then you would have to simplify more in the end. It's up to you. So this does work. We're going to do a denominator of 10. So this gives me 8 over 10 plus 1 over 10. And I add my numerators and I keep my denominator. All right, so before we move on to factoring, I want to know what questions you have on that. All right, so for factoring, we have 3 different types of problems. The first one, we need to know the numbers that multiply to negative 40 and add to negative 3. And so I just made a little list for negative 40, starting with 1 times negative 40, 2 times negative 20, 3 doesn't work, 4 times negative 10, and 5 times negative 8. And then finally, I found the numbers here. So I have x plus 5 times x minus 8. The second one is an example of difference of what? Difference of squares, yeah. So difference of squares is always going to be a plus minus pattern. The x squared comes from the x times the x, and the 36, you take the square root of that and get 6. So it's a 6 times a negative 6 will give you the negative 36. And remember, this difference of squares pattern works because your middle term, which is missing, it's missing because you have a 6x and a negative 6x that cancel out. Last one is a common factor. What number is the biggest number we can divide 6x and 10 by? 2, yeah. So we'll factor out the 2. The 2 comes to the outside, and then we're left with 3x minus 10. Oops, I don't even know what number I was writing there. Minus, 5, right? 5 is the right number. Okay. Put that up. All right, so we're going to do 2 examples, and then you're going to try the 2 practice problems below it. It's an adding problem, so we need a common denominator. Do we have a common denominator? Good. So keep your denominator, and then add your numerators. All right, notice they're not like terms, so I didn't make it 18x, right? Because I can't actually put them together like that. But I can write the expression that shows that they're being added. Now the next thing you want to do is see if anything can factor, because sometimes you get your answer and then your answer will simplify. So then I'm going to factor my numerator. The denominator does not factor. So I'm going to take out a common factor of 6x. When I divide this by 6x, I get x. And when I divide this by 6x, I get 2. All right, so I was hoping something would cancel out. It doesn't cancel out, so I'm good to leave it like this. But if they were both x plus 2 or they were both x minus 2, then they would cancel and you'd have a simplified answer. So you're just done there. Okay, this is a subtraction problem. I have a common denominator, so I'm going to keep it. And then I'm going to subtract my numerator. So my denominator is 6d squared plus 4. My numerator is 5d squared plus 2 minus 2d squared. Do I have any like terms? Yeah, those d squareds can combine. So that's going to give me 3d squared. So I have 3d squared plus 2. All right, which of those has a common factor I can take out, the numerator or the denominator? Tell your group which one has a common factor I can factor out. Is there a number I can divide 3 and 2 by? No. Is there a number I can divide 6 and 4 by? Yeah, I'm going to take a 2 out of that one, so I'm going to factor this one. So, this one stays, 3d squared plus 2. This one I factor out the 2. 6d squared divided by 2 is 3d squared. 4 divided by 2 is 2. So now notice I have the same thing in the numerator and denominator. So when I cancel them, my answer is not 2, it's what number? Ian says 1 over 2. Anybody agree? Desmond says yes. Good. All right, so this equals 1 over 2. All right, so now I need you guys to do the 2 practice problems below. I want to see how you did. Let's quiet down. You should have kept your denominator at x plus 3. Did you do that? And then you're adding your numerators together. You can write the whole thing out, or you can just add them right here. So 3x plus 2x is 5x. And negative 4 plus 5 is positive 1. Does anybody want to see that with more steps? I kind of cut out that middle step. All right, does anything factor? Is there a number we divide 5 and 1 by? Just 1, right? So that doesn't do anything. And x and 3, those are different because one's a variable and one's a number. So we're good. It's just our answer.
So all we're doing is adding.
Mm-hmm. For the next one, we're going to keep your denominator of 5x, but I am going to show the step to subtract because subtracting is tricky. People always forget to distribute the subtraction to both terms. So I'm going to keep the 3x plus 5, and then I'm going to subtract the 4x, and I'm going to subtract the 5. So that subtraction, it distributes to both of these. So 3x plus 5, but then minus 4x and minus 5. So 3x minus 4x gives you negative 1x. And what happens with 5 minus 5? They cancel, right? They're gone. So I have negative 1x over 5x. Does anything else cancel? Your x's cancel, right? Because this is negative 1 times x, 5 times x, and multiplication and division undo each other. So those will cancel, and your final answer is just negative 1/5.
Wait, what canceled?
I'll go back to it. Okay, let's start over. So in the beginning, I kept my common denominator of 5x. I kept the beginning 3x plus 5, and then I wanted to show that my subtraction was going to distribute to both terms.
Yeah.
So then the 3x minus 4x gave me negative 1x, and 5 minus 5 is nothing, so I didn't have another term.
Oh, the 5's canceled.
Yeah. All right. In order to find the least common denominator, you need to start by factoring denominators. Just denominators, okay? Start by factoring denominators only. Oh, can't see any of those words. Here they are. Start by factoring denominators only. So this one, I need the two numbers that multiply to negative 8 and add to 2. Okay, and there they are. So x minus 2 and x plus 4. This one already has x plus 4, so to get a common denominator, I multiply it by what it's missing, the x minus 2. I can only do that in the denominator if I also do it in the numerator. All right. When we combine these, we're going to keep our common denominator, and we're going to have a subtraction that's going to distribute to all of this. So I'm just going to make a big fraction. Start over here. Remember, you just write the denominator one time. Then I have 7x minus 8 minus 6. And that minus 6 is going to distribute to the x minus 2. So 7x minus 8, that's going to make a minus 6x. And then negative times negative makes a plus 12. All right, I'm going to combine like terms. 7x minus 6x is 1x. Negative 8 plus 12 is plus 4. You're going to notice your x plus 4's cancel. So what should I put on the top when my numerators cancel? 1. Good. So that cancels with that, and I end up with 1 over x minus 2.
Wait, what is the x plus 4 at the top?
So I got that from here. 7x minus 6x is 1x. And negative 8 plus 12 is 4. Okay, I'm going to give you like 30 seconds to process, and then we're going to do example 2. Okay, look at your denominators. This one is difference of squares, and so that's going to be that plus minus pattern. So I have x over x plus 3, x minus 3. I know it was difference of squares because my first term is squared, and my second term is 3 squared, which is 9. Plus, this denominator has a common factor of what? Anybody agree with x? Yeah. So both of these can be divided by x. So the x comes to the outside. X squared over x is x. And minus 3x over x is minus 3. So this time it looks like both of the fractions need to be adjusted so that we have a common denominator. So our common denominator is going to have 3 terms. Notice they have the x minus 3 in common, right? This one is missing the x. It's missing this x that's all by itself. In fact, I'm even going to put it like that so that you can see it's a factor. So this one needs to be multiplied by x over x. That's what it's missing. This one is missing the x plus 3. Now I know it has an x plus 3 on top, but that doesn't count. It needs an x plus 3 on the bottom. So this one's going to multiply by x plus 3 over x plus 3. This is probably one of the hardest examples that we're going to do, just because we have 3 terms in our denominator. So each fraction had to be multiplied by what it was missing in the denominator, so that the denominators would match. Now, yeah, they're in a different order, but they're all being multiplied by the same things now, so we do have a common denominator. Then you write your common denominator just one time. X times x is going to give us x squared plus. And then this one I'm going to have to distribute. Remember, you do x times x to get x squared. X times 3 is 3x. 3 times x is another 3x. And 3 times 3 is 9. Okay, 1x squared and 1x squared makes 2x squared. 3x and 3x makes 6x. And then I have plus 9. So I just combine like terms. So now we have to check and see if your numerator will factor. I think we're in luck. I think it won't, but here's how we check. Remember that you have to multiply the first and the last. So are there 2 numbers that multiply to 18? I got that from 2 times 9. And add to 6. 2 numbers that multiply to 18 and add to 6. So 18 is 1 times 18, 2 times 9, 3 times 6. None of these add up to 6, right? So since we can't do that, it can't factor, and so we're in luck, we're just done. Okay, I'm gonna stop there. I will take some questions from the whole class, and then I'll take more questions as I walk around, because you guys are gonna work on the practice problems 1 and 2 here. All right, folks, let's quiet down and make sure you got this, okay? I need you to stop talking. All right, this one, I saw a lot of good work around the room. We wanted a common denominator of 3x, so we had to multiply the first one by 3 over 3. This 3 does distribute to both the x and the 1, so you write your denominator 1 time, and that makes a 3x plus 3, and then plus the x minus 3. So 3x plus 3 makes 4x, and 3 minus 3 cancels out. And then in the last step, you cancel what? X's. Good. Practice 2 was weird because there's nothing to factor. But some of you did notice that we could try to make the denominator the same. So this would be times x plus 3 on the left. And then on the right, what it's missing is the x minus 4. So now what we have is we have 2 fractions with the denominator x plus 3, x minus 4. So we can put those together into 1 fraction, where you write the denominator just 1 time. This one is going to distribute, so I get x squared plus 3x. This minus is hiding down here. It's so hard to see that minus. So what I'm going to do is make it a plus negative so that I can see that that negative 2 is what distributes to the x minus 4. So I just brought the minus up and put it on the 2 so that I wouldn't forget about it. So negative 2x, and then negative times negative is plus 8. So these two combine to give me 1x. So I have x squared plus 1x plus 8, and then x plus 3, x minus 4. Does that numerator factor? Dylan says no. Anybody agree? Cal agrees? Good. I agree too. Because the numbers that multiply to 8 would be 1 times 8 or 2 times 4, and none of those add to 1. So I think we're good. I'm not going to do the last problem because you can get that one from Schoology if you want to do it. But I really wanted to focus in on the basics right now and make sure that we have some time to do some Delta math. Does anybody have any questions on the problems we did do?